on the server end, the system is architected like this. Let's say this is the server. So this is the gateway. What's a gateway? A gateway is a process or a sub-process inside the server that is responsible for communicating with all the client requests. So this is the gateway. So this is the request that's coming in. It hits the gateway. Once it hits the gateway looks for what's called as a dispatcher. This is called as a dispatcher. Okay, this dispatcher is responsible for looking at the request that the gateway has sent, and it looks at what's called as a work process. So these are all work processes. So work process, or let me write it down, it's called a work process. So these are all work processes, and the dispatcher looks at the work process that's free, that's readily available, and dispatches the request to the work process. And this work process will handle this request, do what's required, use the corresponding computing power, and of course it's going to send back a response via the dispatcher to the gateway all the way to the GUI. So when you hit VA01, this is what is happening. So it first goes to the gateway, it then looks for the dispatcher. The dispatcher looks for the available work processes and takes the first stab at the work process. Let's say if it is this work process, it goes here, and if it is the second work process, it goes there. For the third work process, or whatever work process is free, it picks it up and sends the response to that. And the work process will actually look at your request and see that, let's say if it's the creation of a sales order, it will look at the corresponding program that needs to be pulled up, and it will compile the screen and send the screen to the user. Okay, so far so good. What would happen if the users increase? So it's not just me, but there are 300 users. So what would happen then? Number of work process might not be enough. One server might not be enough. There might be more servers that are needed. So what would happen then? So SAP has architected its server in a very scalable way. So let's say again we have this GUI request coming in, and the request is coming to the server, and on the server end, if you want, you can architect it in such a way that you can have more than one server. What do I mean by more than one server? So it's more than one physical piece of hardware. So this is one box of server, this is another server, this is another server. So what are we doing here? We are trying to distribute the load. Right? So we're saying, okay, it's not just you don't need to run this on one server, you can run it on multiple servers. And how do they all communicate with each other? The communication between them is run by one process called the message server. Message server. What's a message server? This communicates between the different pieces of hardware. So what are the processes that are free? What's the server that's lightly loaded? What's the server that's heavily loaded? How can the work be shared between these different servers? Is all taken care of by this message server. And each of these boxes could be running an application server. So app server here, and an app server here also. Okay, the message server is only one, but the app servers could be one per each machine. Now when the request comes in, the request could be routed to any of these different boxes, this or this, depending on which which server is lightly loaded, and the communication between the servers happens via the message server. And in each of these app server, look at the previous picture, each of these app servers, right, boxes really comprises of a gateway, a dispatcher, and a work process. So this is an app server, and each app server consists of a gateway, a dispatcher, and a work process. And you can have more than one app servers with one message server taking care of the interactions between all the different app servers. This is called the application layer. Application layer. Okay. This is all processing in memory, but where is the data stored? The data is stored in another layer called the database layer. This is called the database layer. Database layer. Okay, so probably most of you know what databases are. Most popular examples are Oracle, MySQL, SQL Server, and so on. And between the app server and the database layer, there is a very thin SAP component. Making sure the databases work fine. What do I mean by that? SAP is database agnostic, meaning it doesn't matter if you use Oracle or MySQL or SQL Server. SAP is not bound to a particular type of database. There are instances that use Oracle, for example. Some companies use Oracle, some companies use MySQL, some companies use SQL Server or other certified databases that SAP supports. DB2 is another example. So that's where all the data is stored. This is where the data is stored. So all the tables reside here.